Now we're moving into drawing these little structures of covalent or molecular compounds. So first of all, we fill out a periodic table. And we know in group 1 is one valence electron represented by one dot, and therefore it only wants one bond. Unpaired electrons are the ones that want to form bonds, no lone pairs. Group 2 has two valence electrons, therefore wants two bonds. Beryllium, an example, only wants two bonds, no lone pairs. Group 13, now we're jumping our D block. Remember a D block, the transition metals will act just like column 2. By default, they're going to have two valence electrons. They only want two bonds. Group 13 has three valence electrons. It only does not want a full octet, only wants three bonds. So these were examples of an incomplete octet. Do not give them a full octet. They don't want 8. Now from 14 and below, now you're looking at full octet. So I start out with carbon with 14. Example, carbon has 4 valence electrons, loves 4 bonds, doesn't matter, 4 singles, 2 doubles, 2 singles and a double, a single and a triple. It just loves 4 bonds, no lone pair. Group 15 is we go 1, 2, 3, 4, and we finally pair up once. So group 15 loves 3 bonds and 1 lone pair. That's its preference. Group 16, 1, 2, 3, 4, 5, pair up once, 6, pair up twice. So group 16 loves 2 bonds and 2 lone pairs. Group 17, again we go through 5, we pair up once, pair up 6, and 7 pair up a third time. We see there's only one unpaired electron. So remember, it's the unpaired electron. This is the one that wants to form a bond. This is the one that wants bonds. Here, 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 here. So it's these unpaired, the ones that want to form a bond, not the pairs. The pairs are happy. They're actually in a stable point, so they don't need to form bonds. So group 17 loves 1 bond and 3 lone pairs, and everyone wants to become like a noble gas. Here's the full octet. There's 4 pairs of electrons. There's a full octet. That's what everyone wants to become like, and that's why they're forming bonds, and that's why someone loses, someone gains, because they want the appearance of a noble gas. As we go into this, understand we're using lines representing pairing. Remember, every line represents 2 electrons, and then also when we buy our pairs, buy our dots, we buy them in pairs. But we're only focusing on the valence electrons, which are in the S and the P. Also remember, you have a deficit of 2. We make a single to a double to make up for that deficit. If you fall short by 4, we have 2 choices. You can make a single to a triple, or 2 singles to 2 doubles. Methane is example, CH4, step 1. Step 1, we talk about this. Go total central skeleton happy, total central skeleton happy, total central skeleton happy. So in that process, step 1, I need total. Step 1, total. Where do I go to? I go to the periodic table. Now I just look at the column numbers. So group hydrogen gives me 1. It's in column 1. I have 4 of them, so I have a total of 4. Carbon's in column 14. It gives me 4, so I have a total of 8 electrons to actually work with in the situation. So then my next step, who goes central? Carbon loves to go central. So then after that, I go skeleton. So I go skeleton. Now with the skeleton, I'm connecting everything with single bonds, but remember I have to buy those single bonds. Every bar represents 2 electrons, which is actually $2 in that situation. So I just spent $8. I have $0 in my budget. So then I have to make sure everyone's happy. That hydrogen's happy, that hydrogen's happy, that hydrogen's happy, that hydrogen's happy, and that carbon's happy. Everyone's happy. I spent my budget. I'm done. You're done. So check it all in 2, 4, 6, 8. You spin everything. We go on to ozone. O3. Again, step 1, my total. So oxygen's in group 16. I have 3 of them. Gives me 18 total to work with. So I put my oxygen central, and my skeletal is my next step. So I buy double bonds. I bought 2. Cost me $4. So I pause. I have $14 remaining. Now I go after happy. I see to make my oxygen on outside happy. Remember, look outside first. They both want 6. My oxygen in the middle wants 4. The problem is that's 16. I only have 14 available for me. So I have a deficit of 2. So the rule of deficit of 2 is make a single to a double. Well, I have 2 singles to work with. So in reality, there's actually 2 resonance structures. We talked about that just a little bit because there's 2 possibilities. So let me just put my double bond first of all on this oxygen. And so now the problem is I just spent an extra one. So I've actually had 18, I spent 6. So now I really have $12 in my budget. Do a quick inventory, making everybody happy. I realized to make everyone happy, I need 12. Guess what? I have 12. Buy them. So again, now this one wanted 4. That one wanted 6. That one wanted 2. Buy them. So I check. Happy, 2, 4, 6, 8. Happy, 2, 4, 6, 8. Happy, 2, 4, 6, 8. Remember, every line represents 2. 3 lines is a total of 6. Okay? So, and I spent my whole budget. Now, resident structure, the double bond could have been on the other auction, so I need to write that out. Basically, it's a mirror image almost, but brackets around it. That's why I do resident structures. There are two possible structures here. The next one we ran into is carbon dioxide. Again, step 1 total. So carbon is in group 14, gives me 4. I have 2 auctions though, they're groups 16, so that gives me a total of 12. So I actually have 16 to work with. Who goes central? Carbon. And then I connect my auctions on the outside. There's my skeletal. So my total central skeleton, I just spent $4. I have $12 remaining. Next is happy. I realize to make my auctions happy, they both want 6. To make my carbon happy, it needs 4. Problem once again, I need 16. Problem, I only have 12. I have a deficit of 4. I have 2 choices. Make a single, 2 singles to 2 doubles, or single to a triple. Now I can figure this one out really quick. So if I go back to the table, I will see that my oxygens on the outside love 2 bonds and 2 lone pairs. So they would love double bonds basically. Carbon doesn't care, it just wants 4 bonds. But it could be a double or triple. I'm going to go with double. And I'll show you the triple actually works out too, but the double is more stable. So now I spent $8. Accounting for all my bars. I have $8 remaining. Let's do a happy inventory. So a happy inventory, this auction wants 4, that auction wants 4, and my carbon's happy. It has 2, 4, 6, 8. It has 4 bonds around it, 2 doubles. So I have it, buy it. So I buy it there. And then I'm done with the structure. Now, the thing is, the triple bond, final check, happy, happy, happy. And I spin everything. The triple bond actually works, but it's not the correct way. The actual more stable is the double bond. Auction loves double bond. 2 bonds, 2 lone pairs, so there's preference. The next one we go through is actually carbonate. So in step 1, carbon gives group 14. My auctions in group 16. So I have 3 auctions available, give me 18. My carbon gives me 12, that's 22. But it has a -2 charge, so I actually have, with a -2 charge up there, that means I add an additional 2. So I actually have 24 total I'm actually working with this one. So then who goes central? Well, I do a ratio. I'll put my carbon central. Skeleton, I connect my auctions around it. Just spent $6 in developing my skeleton. I realize now I have $18 left in my budget. Let's do a happy inventory. Do a happy inventory. All my auctions want 6. Guess what? That's my budget. That's my 18 right there. And I haven't got the carbon. Carbon still wants 2. So I have 18, but I need 20. I have a deficit of 2. The rule again is make a single into a double. Well, which one? I have 3 choices. Guess what? You have 3 resonant structures. So again, the double bond could be here, so we'll start out here. Doing a happy inventory. Just spinning 8 now. I have $16 remaining. Doing a happy inventory. I realize that my one auction with the double bond wants 4. My other 2 want 6 still. That's 16. I have 16. Guess what? Buy it. An auction, the carbon in the middle is happy, has 2 singles and a double, it has its 4 bonds. But then now what I have to do is I have to move my double bond around. Could be here, and it could also be down here. So again, 3 structures, I put brackets around it and the charge on the outside. Those have 3 resonant structures. 1, 2, 3 possible structures, all just as stable as the other. That's why I say resonant structures.